Good morning, students. Today we will learn second chapter, Is Matter Around Us Pure? In this chapter, we will come across what is pure substance, what are elements, what is metals, non-metals, metalloids and noble gases, what are the symbols of elements, what is a compound, what is impure substances, that is mixtures, types of mixtures, what is a solution, types of solution, separation of mixtures, physical and chemical changes. The separation of mixture, I have already added a video before, so you will watch that particular in that video. So we will learn more about other topics. Coming to pure substance. You have already heard about the word pure. Often we talk to each other about purity of substances, like pure honey, this is pure cheese, pure water, pure milk. What do you mean by pure? Actually, when we say in normal language, pure means it is very good, healthy, right? But in scientific terms, pure means it is made up of only one constituent. It is not made up of any other. Only a certain thing is only there in this particular substance. See, in the definition you can see a pure substance is a substance that is made up of a single type of particle. So whatever it is, if you break open, every particle will be the same. Only a single type of particle it is made up of. Example is iron, silver, oxygen, sulfur. All these, if you break further also, you will get sulfur, these compounds only, these particles only. So that means nothing else is there, only a single particular type of particle is there. If I say an example of carbon dioxide, it is not a pure substance because carbon dioxide is made up of carbon and oxygen also. So that is not pure substance. So pure substance is always made up of only a single type of particle. Now the characteristics of pure substances. There are certain characteristics of pure substance from which you can identify that it is pure. It has uniform composition. Uniform composition in the sense it is having the same composition everywhere. Everywhere it is having the same composition. So it is called homogeneous. It can't be separated into its constituents. You cannot separate it. It has fixed melting and boiling point, and it always possesses same characteristic properties. Pure substances. What are the categories of pure substances? Elements, compounds, etc. come under pure substance. And impure substances come mixtures. What is mixture? Mixture means it consists of many constituents are there. Many things are there in mixtures. So what is an element? Elements are those substances that can't be broken into more simpler substances. For example, sulfur, sodium, even sugar also. If you break down also, you won't get some other substance. So even if you can't break down it into a simpler substance, then it is the simple most substance. It cannot be broken down further. So that is element. Example is sulfur, sodium, carbon, oxygen. All those are elements. And the characteristics of elements are they are made up of only one atom, one single atom. Physical and chemical properties of elements are same as their atoms. So if oxygen is a atom, then the physical and chemical properties of that atom will be shown by these elements also. Then they occur in nature in free or combined form. Either oxygen, you can see oxygen as a element by itself, but you can see it combines together. Two atom of O and O together forms O2, which is oxygen. And if it is if three atoms of O combine together, it is ozone. So this single O is called an element, and if it combines, it is a compound. Okay. And they can be prepared artificially by nuclear reaction also. They can be solid, liquid, gases at room temperature. Whatever state they can be. Solid elements can be solid, they can be liquid also. There are three elements only which are liquid, and gases also. There are about 11 gases which are 11 elements which are gases at room temperature. Now next is compounds. What are compounds? They are formed when two or more elements combine in fixed whole number ratio. Example, water and NaCl. Again, water, you can see H2O. H, hydrogen is an element. O, oxygen is another element. By combination of hydrogen and oxygen in a fixed ratio, you get a compound of water. Right? So here you can see fixed whole number ratio. It is not like if hydrogen and oxygen mixes, then only one atom of hydrogen and one atom of oxygen, then it will be HO. So there is no molecule of HO. There never can be a molecule or a compound called HO. So hydrogen, if hydrogen is 2, then only one oxygen can combine with it. So this is called a whole number ratio, a fixed whole number ratio. So compounds are formed when two or more elements combine together in a fixed whole number ratio. What are the characteristics of compound? They are homogeneous. They are made up of only a same everywhere. The properties of compounds are entirely different from the constituents. If hydrogen and oxygen together forms water, you know the characteristic of hydrogen. It is a gas. Oxygen, it is also a gas. But what is water? Water is not a gas. It is a liquid. So it is entirely different. Right? So same way, the properties of compounds are entirely different from the constituents. Now constituents can't be separated by physical method. If I cannot take away hydrogen with any physical means. So in compounds it is very difficult to separate the constituents using physical methods. Fixed properties like melting point and boiling point are there. And formation of compound is accompanied by energy changes. There are certain energy changes when this compound is formed. And example for compound is water and NaCl. Even carbon dioxide. Now what are mixtures? Mixtures, it is formed when two or more substances are simply mixed. Now we have seen the save, mixed save, Ferrari, Chivda, all that you can see. There are many things inside it. It is a mixture of many substances. It is called a mixture. What are its main characteristics? It can be homogeneous or heterogeneous. Right? In mixtures, everywhere it can be same constituents. Right? That is homogeneous. But in certain condition, it can be towards one side there are many constituents, and towards the other side there is only there are not every constituent, so it is heterogeneous. Now properties are same as of the constituents. For example, if you consider the save, okay, having all these mixtures, you will get the texture of save, you will get the taste of save, you will get the taste of kadi pata, you will get the taste of chana. You get the taste of and flavor of everything, right? The same way, in mixture also the properties are same as of that of the constituents. Whatever things it is made up of, all the things will be there as a property of the mixture. Now, the constituents can be separated by physical methods. If you consider the save, in this you can pick it up, right? The kadi pata you can pick it up and separate it. Even the chana also you can separate it. So same way, from a mixture, constituents can be separated by physical methods. Now its formation does not require or release any energy. To form a mixture there is no energy needed, or energy is not released also. And properties like melting point and boiling point are not fixed. It may keep on changing. Next is the type of mixtures. Mixtures there are of two types, as we already said: homogeneous mixture and heterogeneous mixture. In homogeneous mixture, you can see almost everywhere the constituents are the same, right? Everywhere it is the same. But in heterogeneous mixture, you can see some part will be different from the other part. If I take certain balls from the upper part and certain balls from lower part, both are having different constituents. So this is called heterogeneous mixture. So this is the difference between types of mixture. Homogeneous mixture is uniform in its property and composition, and heterogeneous does not have any uniform properties and composition. Example for homogeneous mixture is air. Air itself is a mixture of gases. And for heterogeneous mixture, if I put a drop of oil in water, you will see that oil is above the water. It does not mix with water. So it is a separated, and still it is a mixture. Heterogeneous mixture. Now next topic that you have to learn is solution. Solution is a mixture. It is a homogeneous mixture of two or more substances. Okay. The components of the mixtures can be 2, 3, 4 or many. For example is lemonade. In a lemonade, what all are there? What are the components of a lemonade? You will have lemon, you will have ginger, you have sugar, water. There are many constituents in it. Many components are there in this mixture. And it is homogeneous. If you take a drop of lemonade from above also, the taste will be the same. And from below also it is the same. So it is a homogeneous mixture consisting of two or more substances. Generally speaking, solution is binary solution. That means it's having only two components. What are the two components? A solute and a solvent. Let us explain with an example. If I take a glass of water and add sugar into it, okay, after mixing it, what will I get? Yes, sugar solution. So this solution consists of two parts. One is the water, right? One is the water, which is a major part, which is the most of the solution consists water. So water is the solvent part of the solution. Now I added sugar. So this sugar is the solute. So a solution consists mainly of two parts, that is solute and solvent. Now characteristics of a solution. Solution is always homogeneous and the composition may vary. The size of the particles is very small and does not scatter light. If you pass light through it, it will not scatter light, and it can be separated by physical methods because it is not stable. If you heat this sugar solution, what will happen? You can separate the sugar from the sugar solution. Now types of solution. There are mainly three types of solutions: miscible, immiscible and partially miscible liquid. Now miscible liquids are liquids which are able to mix. If you mix two liquids, then both will mix together. Immiscible liquids means they are unable to mix. That means you will be able to see the difference that they are separated. For example is oil and water. If you mix oil in water, you can see that a layer of oil lies above the water, thus indicating that two different layers are there. In this picture also you can see miscible liquid in which these are immiscible. There are 1, 2, 3, right? 3 or 4 sections are there which are not mixed. So these are called immiscible liquids. Now what do you mean by solubility? It is the amount of solute that gets dissolved in given amount of solvent at a particular temperature. If I mix salt in water, how many salt I can put into this water, into this solvent, such a way that it will take all the particle of water. If I keep on adding salt at a particular level, the salt will be found at the base of the vessel. So that particular amount of solute which I can add so that it does not comes under the vessel, it is called solubility. Now concentration of solution. What is concentration of solution? Only we just said it is the amount of solute present in given solution. Okay, how much the amount of solute, how much salt I can put into the solution, into water. This is the concentration of the solution. Now there are it can be measured. There are many methods to measure the concentration. So how to find concentration of a solution? First way of finding is using mass percentage. If you know the mass of the solute, weight of the solute and total mass of the solution, because it is a percentage, how to calculate percentage? So into 100. Mass of solute divided by total mass of the solution. Total mass of the solution means it contains solute and solvent. Total mass of the solution into 100, you will get mass percentage. The same way you can find volume percentage also. How? In the place of mass it will be volume. Volume of solute divided by total volume of solution into 100. Another formula is when we are considering mass and volume percentage, in which the formula will be mass of solute divided by volume of the solution into 100. So using these we can find out the mass or volume or mass volume ratio of the solute and the solution. Now solution are of three types: saturated solution, unsaturated solution and supersaturated solution. What saturated solution? Solution that dissolves as much as solute as it is capable of dissolving. As I said earlier, if in a glass of water you are adding salt, if you keep on adding salt till it can not accommodate more salt. That means on keeping on adding and mixing it, the salt mixes with the water and becomes salt solution. But there is a point at which if you add more salt into it, it will not mix, the salt will remain down. So that particular situation is called saturated solution, where the whole molecule of water has taken up the salt particles. So there is no more water molecules to take the salt particles. So that condition is called saturated solution. In unsaturated solution, solution in which more quantity of solute can be dissolved without rising its temperature. In unsaturated solution, what is the case? It is not fully saturated. There are still water molecules left, so that if you add salt, it can take up. For example, the same case, you are taking a glass of water and putting only 1 spoon of salt. So this solution formed is a salt solution. But if you add more salt, it will take, right? Again it will dissolve in it. If you add 1 more spoon of salt, it may take again. So this particular solution in which there are still water molecules left to take salt particles, this is called unsaturated solution. And in supersaturated solution, what is it? If you add more salt, once the solution is full of salt, again you keep on adding, what happens? The solute remains down. In which, so supersaturated solution is in which amount of solute dissolved is greater than its solubility. That means after the solution is formed also, you will have more solute particles under the solution. Next topic is suspension. What is a suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of a medium. Or in a suspension, the size of the particle is always greater than 10 raised to minus 7. If I mix some sand in water, what happens? A suspension is formed. That means, the mixture of a solid is dispersed in liquid, and you can see the solute particles, they do not dissolve in this medium. And also you can see it with the naked eyes. This in a suspension, the dispersed particle, all those particles you will be able to see with your eyes. The particles cannot pass through filter paper. If I filter it, the particles will not pass through the filter paper. The particles may or may not show Tyndall effect. Tyndall effect means the scattering of light. Only suspension can show or cannot show Tyndall effect or scattering of light. And the particles may settle due to gravity. You can see that when you put sand in water, what happens is particles moves down, then settles according to the gravity. Now next topic is colloid. In colloid you have to learn two different terms, dispersed phase and dispersion medium. Dispersed phase is in colloids. The suspended particles are called dispersed phase. And the solvent in which the suspended particles are suspended, it is called dispersion medium. Milk is a colloid. Okay. Coming on to characteristics of colloid. A colloid appears to be homogeneous, but actually it is a heterogeneous mixture of solute and solvent. As I said, milk is a colloid, and the size of particles is between 10 raised to minus 7 and 10 raised to minus 9. In a colloid, the dispersed particles can be seen with powerful microscope, and the particles can pass through ordinary filter paper. And the particle shows Tyndall effect, and the particles does not settle down due to gravity. It is throughout the liquid. Now let us see what is Tyndall effect clearly. Tyndall effect, it is a process of scattering of light by colloidal particles, due to which the path of the light will be visible. In this particular figure, you can see there is a mixture of fluor and water, a colloidal mixture of fluor and water. And if I pass a light through the torch, the path of the light is visible. Why? Because it scatters the light. So this is called Tyndall effect. Another type of movement shown by colloidal particles is Brownian movement. Here what happens is, the colloidal particles itself move in a zigzag way, and this movement is known as Brownian movement. And with that we come to the end of this chapter. Have a good day. Stay safe. Stay happy.